Hi, I'm Mike Hutjens, Extension Dairy Specialist at the University of Illinois. This module will look at forage feeding strategies with emphasis on hay systems. Let's begin by looking at the forage characteristics of baled hay. The dry matter content will vary depending on the time of the year and in some cases the package. From 78% dry matter, which is typically at harvest time coming right out of the field, to as high as 90+% coming out of storage, because the feed has gone through a sweat or we drive off some of the moisture. The hay packages can be very small squares, which can be as light as 40 to 60 pounds, or big or round bales, big square bales, which can vary from 600 to 1,000 pounds depending on its dimension. And of course, we still have the traditional haystacks out there that Heston and other companies will make. So there's lots of different kinds of packages we can look at depending on equipment, labor, and storage conditions. The larger the package, however, really requires drier hay because we tend to have a denser package and we can have more molding to occur in the middle of these very larger, more dense packages. Let's look at some advantages of the hay system on the dairy farm. Certainly one big advantage is that we can store the hay for long periods of time. Here we're talking years if need be. Second, if I have to transport the product, especially in the western parts of the United States, our costs will be lower because of the low moisture content, and in many cases the very convenience of the package itself, the big square dense bales, for example. Thirdly, baled hay does provide an excellent source of long fiber. We normally define long functional fiber something over 3/4 to 1 inch in length to cause a hay mat and rumination in the dairy cow. Another advantage will be the removal rates from storage can be on an as-needed basis. This will not be true for our silage systems that we'll talk about a bit later. And of course, fifthly, if we have excess of forage on the farm, it can be marketed either locally or long distances depending on requirements and animal numbers on the farm. Of course, with advantages, there are also disadvantages of a hay-based system. Perhaps the most difficult one is the lower quality due to losses that occur at several different points. Generally, we assume field losses can be as high as 20%, and in some cases even higher depending on rain damage, mold, and other losses. It is common to lose the entire crop from time to time because of losses in the field. Storage losses are usually quite low because the dry, stable product, unless it goes through a significant sweat and mold develops. Storage losses typically in that 5% range. The third loss that can occur with baled hay is going to be feeding losses because cows can sort it, select, throw it, nuzzle it, and in essence, just not eat the doggone stuff. And these can be as high as 30%. So you can see we can have some real losses in quantity and quality in the feeding and management program. Secondly, it's very difficult to add large amounts of baled hay to some TMR mixers due to its mixing and shearing abilities of the unit. So certainly if you're going to feed 15 or 20 pounds of baled hay, in many cases that takes you out of the TMR window, which is very popular in the larger herds here in the U.S. To overcome this, some farmers will process it for the TMR. The problem, however, is when you process the hay, we will lose as much as 2+% of the crude protein. This is the leaf, so that green dust or cloud that we see out there actually is the highest quality feed being lost on the dairy farm that we cannot get into the high-producing dairy cow ration. And of course, as mentioned earlier, long hay, especially over 1.5 inches, is very sortable. So certainly the cow can have a different ration that we calculated on a piece of paper, and that can have an impact on rumen function. Now let's finish up with looking at some of the management considerations when we look at a hay-based system. Generally, we want 5 pounds of long fiber in the feeding program. As we defined earlier, this is 1 inch in length by Wisconsin workers, 3/4 of an inch by Penn State workers. So if we're feeding 6 or 7 pounds of long hay and we do not process it or grind it too finely, this almost guarantees this long fiber. That's why many farmers feed 5 or 6 pounds of baled hay every day, just to be safe to ensure they have proper length in the rumen. Certainly we must be always aware of quality concerns, and we must manage this both in terms of cutting times and also in how we handle and store the feed. Certainly drying time is critical, especially our first crop, because it may require 3 continuous days of rain-free environment. And in many areas in the Midwest, that just doesn't happen in May and early June. So drying time can be a real problem. Number 4, use of an acid preservative such as propionic acid or salts of propionic acid can be used to minimize mold formation in the hay at the time of harvest and during storage. And of course, the big factor is hay is not required if other forages can provide the functional fiber needed in the dairy ration. Another factor in managing baled hay is to be sure to check how you process the hay. The Penn State box is an excellent tool because if you overprocess it, we can have over 50% of the hay in the bottom box. This means it has no functional fiber. Also, you have to be sure when we process the hay, we don't cause a great deal of fine and dust. And of course, in storage, you can see piles of leaves and piles of stem. So it means when you put in 100 or 200 pounds of hay, you may not get exactly what we expected to have in the ration itself. We know the harvest window for any of our grass legume forages is 5 to 7 days. The thumb rule from Wisconsin is for every day that we delay harvesting the alfalfa grass, we will drop 4 to 7 relative feed value units. So you can see if we have to take 7 days, we can change as many as 35 relative feed value points. Our guideline for high producing cows is to have a relative feed value over 150 at the time of feeding going into the cow. So you can see we have to start harvesting quite a bit earlier to guarantee a minimum value of 150. We also know that baled hay works nicely in smaller herd sizes that does not have to store huge amounts of feed. I define that for herds under 75 cows. This may be a good system to look at as far as handling and storage forages on the farm. Another aspect you consider is the hay drying agent. This is a salt that literally helps pull moisture out of the plant itself, reducing drying time by as much as 1 day. These require fairly large amounts of water and fairly good management to get the job done, but it's another way to accelerate the drying time. And finally, when are you going to cut the hay? If you read in the forage magazines, there's great controversy. Should you cut it in the morning or cut it in the afternoon? If you cut it in the afternoon, you will have a higher sugar content in the alfalfa at the time of cutting, which means you have more soluble carbohydrate, which could improve both quality and fermentation characteristics if it happened to be a haylage. However, when you then cut late in the afternoon, then all night that plant will respire. It is still too wet. It is still trying to live, and it will respire and burn up much of this carbohydrate, and therefore we can lose a lot of the advantage there. So there's a great deal of controversy, but the bottom line is make sure you have high quality forage. So don't try to change cutting times if it results in a risk of rain damage or delay cutting in the feeding program. Well, this completes our module on hay, both legumes and grasses. Thanks and have a good day.